With 9 months elapsed in the 2013-2014 operating year, the Intermountain Power Project is posting solid gains in every key operations measurement. Located in Millard County, Utah, the Intermountain Generating Station commenced operations in 1986. Its twin coal-fueled units generate enough electricity to supply approximately 1.5 million homes throughout the West. A review of the past 5 years shows how Intermountain has overcome significant operating challenges to regain its status as one of the top-performing coal-fueled power stations in America. In the first 9 months of 2009-2010, Intermountain set records for best performance in project history in 4 key operating areas: forced outage rate, equivalent forced outage rate, equivalent unplanned outage rate, and unit shutdowns. Only 5 unit shutdowns were recorded the entire period. In the first 9 months of fiscal year 2010-2011, however, performance turned around in several categories when Intermountain incurred major planned maintenance outages on both generating units. Ordinarily, only one unit receives major maintenance each year, but maintenance on one unit was deferred from the prior year in order to facilitate upgrades to the southern transmission system. The situation was complicated when the Unit 2 maintenance outage revealed cracking in Unit 2 low-pressure turbine blades that required temporary installation of pressure plates while new blades could be manufactured. 2010-2011's operating record during this period suffered as a result, logging worst in project history performance in 4 key categories: net generation, coal usage, equivalent availability factor, and unit shutdowns. In the first 9 months of 2011-2012, challenges continued with an unusual equipment failure that led to a 151-day unscheduled repair outage for Unit 1. On December 28, 2011, a connector in the Unit 1 generator catastrophically failed. The total cost to repair Unit 1 was approximately $17 million, and the performance impact of this single equipment failure was significant. 2011-2012's operating record during this period logged worst in project history performance in 6 key categories: gross generation, availability, forced outage rate, equivalent forced outage rate, equivalent unplanned outage rate, and net capacity factor. In 2012-2013, Intermountain completed recovery from the Unit 1 generator connector failure and also completed installation of new low-pressure turbine blades in response to the cracking discovered 2 years earlier. Net output factor charted a project history low during the first 9 months of the year, but this was related to reduced dispatched load, not operating performance. Most measurements of efficiency and reliability began a solid rebound. That rebound continues into the current year, and Intermountain is once again operating at full stride. During the first 9 months of the 2014 operating year, Intermountain incurred only 7 unit shutdowns, the 3rd best performance in the past 10 years. Gross and net generation, coal usage, availability, equivalent availability, and capacity factor are all improved over the prior year's performance. For the first 9 months of 2013-2014, Intermountain's gross and net generation was 10,317 gigawatt-hours and 9,703 gigawatt-hours as compared to a 10-year average of 10,952 and 10,309 gigawatt-hours. Coal usage was 4.25 million tons as compared to a 10-year average of 4.38 million tons. Coal heating value was 11,129 BTU per pound, as compared to a 10-year average of 11,351 BTU per pound. A 6-week scheduled maintenance outage for Unit 1 was completed at the end of April 2014. Work on the turbine generator included high-pressure rotor buckets were polished and all non-destructive examination on the rotor was completed. High-pressure N2 packing gland was weld repaired due to damage sustained during the removal process. Intermediate pressure rotor 8th and 9th stage buckets and covers on the turbine and generator ends were replaced along with bucket covers on the 10th stage due to solid particle erosion and foreign object damage, and all non-destructive examination on the rotor was completed. High pressure and intermediate pressure diaphragms were repaired and new spill strips installed. Control and stop valves were replaced with a rebuilt set. Turbine lube oil system was filtered and dehydrated due to water contamination issues during shutdown. The mechanical overspeed trip was replaced with an electronic system. Generator had several new temperature and 1 new vibration sensors replaced on the T4, T5, and T6 connections. Generator protection relays were upgraded and high pot testing completed. Major maintenance was also conducted on Intermountain's Unit 1 transformers. The generator step-up transformer oil was drained and internal inspection done to locate a suspected arcing problem responsible for dissolved gases being detected by oil samples and the Sevron online gas analysis continuous monitoring system. A problem was found with the connections on the splice plates for the flux shield jumpers, flux shield supports, and the flexible copper straps. Replacement splice plates. New bolts were installed over this last weekend. 2 leaking current transducer penetrations were repaired. 1B auxiliary transformer had the X and Y neutral bushings replaced due to poor Doppel numbers, and the conservator bladder was replaced. Maintenance in the boiler area included B and C coal mills were overhauled and new Techonomics throats installed. The B mill had new ceramic tires installed and the old table elements were reused. The C mill got all new ceramic parts and a new ring seat, being converted from Alstom components. Boiler quick deck was installed for inspections and repairs in the pendant area, and sky climbers were used for the burners and water wall tubes. Reheat pendant area was found with 9 improper material tubes that were cut out, and the proper material was bent and welded back in. Fuel oil igniters to meet the EPA MATS rule requirements were installed. These igniters require more airflow, and significant upgrade work has been accomplished to meet these requirements. Boiler seal trough skirting and screens to protect the seal trough header have been replaced. Finally, one of Intermountain's most remarkable operating accomplishments concluded on February 12, 2014, when Unit 1 experienced a boiler tube leak. Boiler tube leaks, which are common at large coal-fueled power plants, are an unusual event at Intermountain because of the project's aggressive boiler tube failure reduction program. Prior to the February incident, Unit 1 had not experienced a leak since March 12, 2011, an unparalleled performance of almost 3 leak-free years. Unit 2 will reach 3 leak-free years on September 10th if its current streak continues. Skill, dedication, and pride from Intermountain's experienced workforce makes remarkable achievements like this possible. Their demonstrated ability to overcome adversity is once again paying off as Intermountain returns to the high performance levels that have characterized over a quarter century of efficient and reliable service.